So first and foremost, just changing the blade. Main plate, lift up the lock. This saw uses 2 wrenches. This big flat one goes to the left of the blade, in between the actual housing and the blade. The other one, I don't know why it gives you 2 ends, but use this end. Also, when we put these blades on all of our machines, the rotation of all of these machines inherently tighten themselves. We just need to snug them up. We don't need to like gorilla tighten. The nut on this machine looks pretty beat up, so we don't have to go like crazy when we tighten things. This saw also has an additional plate, just helps keep the blade straight. So we always need this. So yeah, blade comes off, goes back on opposite way. Next one, changing the cartridge on this. To change the cartridge on this machine, there's that red lever inside. That's the locking key. You turn it, quarter turn, pull the key out. These things are kind of a pain in the neck to get out. I usually use this tool as a pry bar because there's a pin at the top and the bottom of the cartridge. So you kind of have to like do a little on one side, a little on the other side, and then it comes out. It does have a plug on it because it reads electronically, so making sure that's clear of dust and everything before you put it back in is very important. The 2 different cartridges that we use, they're pretty easy to tell apart. The one for the regular blade is skinnier and much lower profile because we use a 10-inch blade for the dados. You can see it's got the wider faceplate for catching all the blades, and it's much beefier because it's an 8-inch diameter. So put them back on just like you take them off. The top pin is a little hard to see. It's right underneath the clamp for the arriving knife. So that one's a little tougher to get on, but I usually get that one started first and then get the bottom pin lined up and then push it straight in. Give it a good push so it gets seated, and then the key goes back in and locks down, and that's it.
Two hours later.
So yeah, when we're tightening, I mean literally just, that's all you need. On any of these, I don't want to see pipes over here. It's completely unnecessary. You'll crack the nuts, you'll crack the housing. All right, for this saw, it's great, it's very safe, but makes things a little frustrating sometimes. So like, as you can see, I just changed the blade. So right now, we've got a red light blinking, so that thing won't turn on. Anytime you get an error code, just turn it off. Count to fucking 3 and turn it back on. It needs a second, it doesn't instantly go on. So right now you'll see a green light with a blinking red light. Once the red light stops blinking. So anything that can conduct electricity is gonna set this brake off. Pressure treated wood, even if you notice any wood that's too wet, for sure metal. 4 fingers, but it makes a few other things complicated. We can cut those things on here. You just have to turn the safety system off. The main thing to keep in mind with turning off the safety system is every time you turn it off and turn it back on, it's turning it back on. I try to just get everything ready because I know I've almost done it like 4 times where I turn it off and I'm about to make the cut, and then yeah, those cartridges are, you know, 120 bucks a pop, so they're worth it. Less expensive than a finger, but sucks to lose them for dumb mistakes. So turn the brake off. There's a key over here on the side. Turn it until the light blinks red and green, and the green light starts blinking. Turn it on. If it's on and the green light's blinking, that means your brake is on. As soon as you turn it off, I'm still getting a blinking green light. We got a solid green light. And that's solid green light. Every time we turn it off, we need to do that process again to restart it if we're cutting a bunch of brass or aluminum or whatever. Outside of that, it's basic table saw. Your adjustment wheel in the front will do your height. Your adjustment wheel on the side will do your angle. There is a readout gauge, but I'd always like to double check and verify that, which actually is probably a good thing to keep in here as well, as an angle gauge. One thing I noticed we have not been great about is trusting those gauges and trusting stops. We do have squares that we've been keeping in here, but anytime we put a bevel on the saw, 99% of what we do is going to be square cuts, but we need to check it with the square. Don't just trust the saw, because I mean, if we're trying to do face frame material, I trust doing square edges on a saw more than I do on a jointer or anything else. And I usually rip things big, and then I'll take them through the planer and get the sides parallel. But this is usually how I'm putting my square edge on a piece. But if you're not cutting it square, all of that's going to continue to transfer down the line, and then you got a face frame with 3-degree bevels on every side. So anytime we put something at a square, whether it's this saw or that saw, check it for square again. Don't just get it close. That big thick line in the arrow that's on a flimsy piece of aluminum said it was 0. You know what I mean? We need to verify. You should be able to get up under here. I don't like to do it off of the base plate. I like to do it off of the steel of the table, because that's what the majority of your piece is going to ride on. But like right there, I can see daylight through that thing, so I'm canted this way. This is not square for now.
Later that same evening.
Like right there, I can't see daylight through there anymore. So that is square. Making sure I'm keeping my pressure on this side. I'm done. Dado blades, same thing. We make sure we have that cartridge in there. All of these blade sets usually come the same way. We have our 2 full blades, which are always going to be your 2 outermost blades. When you look at them, you have a flat blade and then another tooth that comes to a point. The pointed ones are your outside scoring blades. So if you look at these 2 sets, one points that way, one points that way. So this is your left blade, this is your right blade. Can't switch them. I mean, you can, it'll flip cut, but your data's gonna look like shit and it's not gonna be square in the corners. So yeah, these are always your 2 outermost blades. All the blades are pretty well calibrated. That each blade is going to be an 1/8, and then there's one in here that's skinnier than the rest, and that's a 16th. So usually if you're going to a full 1/8 or a full 16th, you shouldn't have to measure anything. You shouldn't have to mess with shims. But there are times where if you're trying to make a dado that another piece will fit in, if it's plywood, it might not be exactly 11/16 or exactly 3/4. So there's a whole bunch of different shims in here that you can put in between the blades. I usually don't, you get a little bit of overlap on the teeth when you stack all of these together. So you do have room to put the shims in there. But if I'm trying to shim a 32nd, I usually don't put all of my shims in between 2 blades and have the rest. Like if I need 2 or 3 shims, I'll put one in between one blade, put a blade on, put another shim, put another blade on, try to spread that out a little bit, just to kind of evenly space it out, and then that way you're also not left with a gap between 2 of your teeth, which again will just give you something you have to come back and clean out of your dado. Just because I'm looking at it, blade cleaning, keeping the blades clean is important. It will extend the life of the blade. Sometimes it will start cutting like it's dull, but it's really just dirty. Wood has sap in it, so they also call pitch. Just from the speed and the friction of the blade going through the wood, it starts getting all of this burnt built up on there, which is just going to then continue to cause even more heat, because now you're building a layer on top of the blade, which is just rubbing. It's going to burn your pieces, which is a pain in the neck to sand off. It's going to make it harder to push it through the saw. So keeping clean blades, that is why we have these plates on the front of both of these boxes, just so you have a clean surface. Our surface to not get everything else dirty. We have more of this in the supply room. This is just blade cleaner all around. Saw blades, router blades, anything that's meant to get that pitch off. And then a wire brush. Why we have this plate, it's just this is corrosive stuff, so we don't want to be spraying it all over. Kind of burns on your fingers, and I've had a lot of it on my hands, but it's probably not good for you. I usually spray it on, let it sit for a minute. It does a lot of the work on its own. You don't have to wait too long though. And then a wire brush. I know these aren't supposed to hurt the blades with carbide teeth, but I try to just not like run it into the blade. I try to like run it out this way or the opposite direction that the blade cuts, just so we're not putting all that torque on the teeth. This blade is particularly bad, but you know, the light stuff's coming off real easy, but it might take a little work to really get in there. And where this one's so bad too, I mean, sometimes coming in and kind of scraping off the top layer and letting the cleaner work in there is good.
6 months later.
And again with this, if it's something we stay on top of, it's easier to do sooner than later. But yeah, the main part, I mean, obviously while we're doing it, let's get the whole blade clean. The most important part, I would say though, is the actual carbide on the teeth, which, you know, you can see usually most blades are made out of steel. And you can tell there's a different material where it's just the tooth, that's the carbide. So you know, getting the sides of it, getting the top edge of it, and you can see it's a little thicker than the steel, so that's your actual cutting face. So getting everything around that thing clean is gonna mean that the carbide's making contact and not just the pitch that's built up on the carbide. So it's gonna make your blade sharp, stop all the friction, stop all the heat, make it cleaner to cut.
I guess I gotta clean this whole blade now.
$12 midnight.
So yeah, there's still a little bit of pitch, but you know, so this could be gone over again, but it's all on the steel. Carbide's clean. But yes, this one has a thermal breaker on it that is right behind the switch. So you have to shut it down. I think you have to wait like 2 or 3 minutes and then it will click and it will let you, when it's pressed in all the way, you're good to go because it pops back out. But you know, when you first press it, it won't even stay in because I think it needs to cool down just a little bit. But you know, also with that stuff, the rate at which you're speeding, the sharpness of your blade, sometimes, you know, if we're getting to the point where we're bogging things down, we might have to do things in 2 passes. I know, like me and Angel, when we made those mullions, and we were still doing it, but we had to do a 1-inch deep dado in white oak, and you know, I had to do that 2 passes. So I went up, you know, 1/2 inch first, ran everything, went back and did another 1/2 inch and did everything. Could you do it in 1 pass? Yes, but we would be feeding like this fucking slow, which, you know, it was burning up, it was heating up, it was not great. So it took us a little, actually it might have even been faster because we were able to feed it faster, only taking a 1/2 inch, but we weren't burning the material. And, you know, just, so you got to be strategic about how you do this. You got to listen to the machine. And then, yeah, if you're not dealing with having to stop and let the thing cool down for the breaker to turn back on, you're saving time there too. So sometimes it might be 2 passes, but it's safer. I mean, kind of like when we ran that base for Dominion as well. You know, it just, the machine couldn't handle taking all that material out 1 pass, so we had to hog it out. Yeah, I've had instances where we've done that on, or you know, I've had moldings we've had to do where, you know, actually putting it on the saw and like cutting out a chunk sometimes it's faster. But these machines all have different power ratings, but some are better for other things. Learning the limits of the machines is also important, and then being strategic about how we tackle things, because yeah, might save us more time, fingers, the whole machine, those kind of things.